Today on Quickly Quantum, a quantum chip just did something with subatomic particles that sounds like science fiction, braiding and fusing exotic quasiparticles called anyons to unlock a universal set of quantum gates nobody's pulled off quite this way before. Before that, in the headlines, the European Space Agency's first quantum computer just landed in Italy. Germany gets its first pure-play public quantum stock. India says its military-grade quantum encryption just passed field trials. And Jane Goodall's chimpanzee research is getting a quantum computing partner. Welcome back to Quickly Quantum, your daily brief on the quantum frontier. It's Thursday, July 16th, 2026. Let's get into it. Now, first up, Europe's space agency just got its first quantum computer. The European Space Agency has installed a system called Bell 1 at its Earth Observation Center, ESRIN, in Frascati, Italy. Bell 1 comes from a company called Equal 1, and it's a 6-qubit machine built on silicon spin qubits, quantum bits made with fairly standard chip fabrication techniques, which is why this thing runs at a relatively warm 0.3 Kelvin instead of the near absolute zero most quantum computers need. That means it's small enough to rack mount, with a cooling system drawing just 1.6 kilowatts. ESA's plan is to pair Bell 1 with classical supercomputers to speed up satellite data analysis, with a pilot by the end of the year covering land classification and mission planning. As at ATU URULLA04 put it on X, quoting the announcement, the European Space Agency has installed its first quantum computer, called Bell 1, at its Earth Observation Center in Italy. Now, 6 qubits is a research toy, not a production tool. This is prototyping, not proven quantum advantage for satellites. But it's a real foothold. Now, over in Germany, Quantum just got its first hometown stock. Munich-based Aquarios has listed on the Dusseldorf exchange after merging with a SPAC called Fontarelli SPAC 4 AG, raising roughly $140 million. The company says it's Germany's first pure-play publicly listed quantum computing company, meaning quantum is the whole business, not a side project. Aquarios spun out of LMU Munich back in 2021, and its Luna platform, a hardware-agnostic optimization tool, already counts BASF, Ion, and MTU Aero engines as customers. Here's the catch. Per German securities filings, Aquarios' annual revenue has been running in the 1.1 to 1.4 million euro range, swinging between about 193,000 euros in profit and a 459,000 euro loss. That's a real business, but a small one relative to the SPAC headline, and it lands amid what's been a historically active year for quantum SPACs and IPOs globally, so investor appetite is clearly there, whether the fundamentals have fully caught up or not. Now, a defense story out of India. DRDO, the Defense Research and Development Organization, says it's completed military field trials of a homegrown quantum key distribution system built with a Bengaluru startup called TACBit Labs. QKD uses quantum mechanics to detect eavesdropping on encrypted communications, and the pitch here is defense against harvest now, decrypt later attacks, where adversaries hoover up encrypted data today, banking on future quantum computers to crack it open later. That puts India in a small club of countries actively fielding quantum-secure networks for national security, alongside China's large-scale, MICHIS satellite-linked QKD infrastructure. As at Ravis RM511 put it on X, DRDO achieves quantum milestone. DRDO has successfully completed military field trials of a scalable, fiber-based quantum key distribution system with TACBit Labs, Bengaluru. One caveat, this comes from a government and agency announcement rather than an independently peer-reviewed benchmark, so specifics like key rates and distances aren't independently verified, though multiple Indian outlets have now picked up the claim. Now for the story that made me smile this morning. The Jane Goodall Institute USA is teaming up with a quantum startup called Formation Q, using IonQ's trapped ion quantum computers to dig into one of behavioral ecology's oldest puzzles: why chimpanzees wage organized warfare between groups while bonobos, our other closest living relatives, coexist peacefully. As at Formation Q _ announced on X, today, on World Chimpanzee Day, we're proud to announce a landmark collaboration between Jane Goodall Institute and Formation Q, using IonQ's trapped ion quantum technology to explore one of behavioral ecology's biggest questions. It's a 2-year program applying quantum computing to decades of Dr. Goodall's own field data. At Tech Innovations added more color on X, tracing the history back to Goodall's original 1970s observations, before noting the program's ambition to model that behavioral gap computationally. It's an early-stage collaboration, not a proven case where quantum beats classical modeling, but it's a genuinely fresh use case for the tech. Now, some executive shuffling at PsiQuantum. The company named Rob Soderberry as Executive Vice President and Sriram Sitaraman as Chief Information Officer, rounding out its leadership bench under Victor Peng, who was confirmed as permanent CEO after serving as interim. In its own announcement on X, PsiQuantum called it an exciting new chapter, with Soderberry focused on scaling the company's silicon photonics platform and Sitaraman running global IT. Notably, the U.S. ambassador to the U.K. at USAMB UK weighed in too, posting on X after a conversation with CEO Victor Peng and CTO Mark Thompson. The United States wants to see more U.S. and U.K. companies like PsiQuantum pushing the frontiers of technology and delivering economic growth in both our countries. That's a fairly high-profile diplomatic shout-out for a personnel announcement. There's no new technical or financial disclosure here, standard leadership team PR, but it shows PsiQuantum's continued push toward a utility-scale, fault-tolerant machine, and it's drawing attention well beyond the usual trade press. And finally, we told you yesterday that D-Wave was moving its stock listing from the New York Stock Exchange to Nasdaq. Now we've got the actual date, July 27th. D-Wave also tacked on a new claim this time around, touting 99.9% uptime for its quantum annealing system. Investor at Ailsa Forshaw was thrilled, posting on X, "Wow, this is amazing for $QBTS," quoting D-Wave CEO Dr. Alan Baratz, calling Nasdaq the marketplace for companies shaping the future of technology. Changing exchanges is a visibility and market structure move, not a technical or financial catalyst on its own. And that uptime number is D-Wave's own reported metric, not an independently audited figure. Still, mark your calendar. July 27th is when it actually happens. Now, let's get to the story that's got the whole anyone chasing corner of this industry talking. Our main story today, what I'm calling the fusion fix. How Quantinuum just found the missing ingredient for building quantum computers out of exotic particles instead of ordinary qubits. Here's the setup, published in Nature. Quantinuum, working with academic collaborators, took its H2 trapped ion processor, a quantum computer where each qubit is a single trapped charged atom controlled by lasers, and used 54 of its qubits to prepare something called a non-Abelian topological order. Let's unpack that plainly, because the payoff is worth it. In certain exotic states of matter, you can create quasi-particles called anyons. Think of them as little knots of quantum information woven into the fabric of the system itself. Move two anyons around each other, braiding them, and depending on the path they take, you change the quantum state in a way that's remarkably hard for noise to mess up, because the information isn't sitting in one fragile spot, it's smeared across the topology of the whole system. That resistance to noise is the entire appeal. Error protection baked into the physics, rather than bolted on after the fact with the heavy overhead of conventional error correction. The problem, until now, was that braiding alone doesn't give you every gate you need. Quantinuum showed this back in 2024 in an earlier Nature paper, using 27 qubits to build something called D4 topological order and braiding anyons successfully. But the gate set from braiding alone in that model wasn't universal, meaning some operations a general-purpose quantum computer needs simply weren't reachable. This new paper attacks that gap directly and scales up while doing it. The team used the quantum double of S3, the smallest possible non-Abelian group and thus the simplest playground for this physics, and found that adding anyon fusion, where two anyons combine and annihilate into a new quasi-particle, as a computational move alongside braiding, makes the combination universal. They proved it by preparing what's called a magic state, the standard benchmark for showing a system can do universal quantum computing. Why should you care if you'd never heard the word anyon before today? Because this is one of the more credible-looking paths toward fault-tolerant quantum computing. Machines with error rates low enough to run real, long algorithms that doesn't rely purely on the brute force error correction IBM and Google are racing to scale. And it's landing in a genuinely crowded field. Google and IBM have both published their own Anyon braiding demonstrations on superconducting hardware, and Microsoft has bet its entire company roadmap on topological qubits working. Credible progress toward universal gates via anyons on any hardware gets watched closely across the whole industry. So here's my read on where this actually sits. This is a proof of principle on a 54-qubit NISQ-era system, noisy intermediate-scale quantum, today's imperfect machines, not a fault-tolerant demonstration running an error-corrected algorithm end-to-end. Quantinuum has shown fusion-based universality is possible for this particular topological order, the S3 case. That's different from showing it beats or even matches conventional error correction at scale. It's a "this can be done" result, not a "this is now the best way" result. And there's a pattern worth naming because it's the honest skeptic's note on basically every Anyon paper lately. Non-Abelian Anyon claims have a track record of incremental one-upping across labs. Google publishes a braiding demonstration on superconducting hardware. Quantinuum answers with trapped ions. Academic groups chime in with their own variants. And with each new paper, the definition of first gets redrawn along a narrower technical axis. That's not a knock on the science, which is genuinely rigorous. It's a caution about the marketing gloss that tends to follow it. What makes this result stand out from that pattern is the choice of S3 itself. By deliberately picking the smallest, simplest non-Abelian group instead of chasing something flashier, the team gave itself a cleaner proving ground. And the fact that fusion unlocks universality even in the minimal case is a stronger signal for scalability than if they'd needed some exotic, complicated group to make it work. It's worth sitting with why anyone wants this at all instead of just piling on physical qubits and error correction, which is IBM and Google's playbook. The pitch for topological quantum computing has always been that error protection is built into the geometry of the system itself, rather than requiring hundreds of physical qubits to protect one logical qubit, the error-corrected qubit built from many physical ones that actually does useful work. If that promise holds at scale, it could mean dramatically smaller hardware overhead for a fault-tolerant machine. That's the entire bet Microsoft has made with its whole company roadmap, and it's a big part of why every credible step in this direction gets this much attention, regardless of lab or hardware platform. Now, time for the hype check. I'm putting this one at a 7. Number first, as promised, a real Nature paper, a legitimate scaling jump from 27 to 54 qubits, and a genuinely new theoretical insight that fusion, not just braiding, is the missing ingredient for universality that other groups now have to engage with. That's substantial. It loses points for the same reason nearly every Anyon paper does. This is proof of principle on noisy hardware, not fault-tolerant, and the field's habit of redefining first along narrower lines means today's milestone is one entry in a fast-moving, competitive sequence, not a finish line. Watch for whether Google, IBM, or the academic superconducting Anyon groups replicate the fusion trick on their own hardware. That's the tell for whether this is a durable technique or just Quantinuum's latest lap around the track. These are threads we'll keep pulling on this week, especially as we watch whether anyone else answers Quantinuum's fusion trick. If the show's earning your time, hit follow wherever you're listening. It genuinely helps more people find this. That's Quickly Quantum for today. New episodes every day. This is an AI-voiced podcast created and built by a real person using today's cutting-edge technology. And remember, nothing on this show is financial advice. I'm Brian Lampert. See you tomorrow.